We live on a world we think we know. We have mapped its continents, sailed its oceans, and named its highest peaks. From the vantage point of space, our home is a familiar blue marble, a beacon of life in the vast cosmic dark. Yet, this familiarity is a grand illusion. We have barely scratched the surface of our own planet. Beneath our feet, under the crushing pressure of rock and water, lies a realm of secrets so profound, they challenge our understanding of life, geology, and the very history of our world. Most of our planet remains an uncharted wilderness, a frontier far more alien than the surface of the moon. Imagine standing on the shore, looking out at the endless expanse of the sea. Now, imagine that the deepest part of that ocean is only a fraction of the way to the true mysteries below. We have sent probes to the farthest reaches of the solar system, but the journey to the center of our own Earth is a voyage we have only just begun. Down there in the perpetual darkness are forces that shape our daily lives in ways we are only now beginning to comprehend. The ground we stand on is not solid and unchanging. It is a dynamic, living system, full of wonders waiting to be discovered. Our quest for knowledge has always pushed us to look up at the stars, to wonder about our place in the universe. But an equally grand adventure awaits us in the opposite direction. What lies miles beneath the soil? What secrets are held within the planet's fiery heart? The answers are not just matters of scientific curiosity, they are tied to the very survival of our species. Understanding these hidden features helps us prepare for natural disasters, find new resources, and appreciate the delicate balance that makes life on Earth possible. The story of our planet is far from finished. In this journey, we will pull back the curtain on some of Earth's most amazing hidden secrets. We will travel to a hidden biosphere teeming with bizarre life, uncover an ocean larger than all the ones we know combined, and trace the path of a river flowing under an entire continent of ice. Each discovery is a chapter in the epic story of Earth, a reminder that our planet is a place of endless wonder and surprise. The greatest explorations of the 21st century may not be to other planets, but deep into the heart of our own. Prepare to see your world in a completely new light. Deep beneath our feet, far from the sunlit world we know, exists a vast and ancient ecosystem. Scientists have dubbed this place the subterranean Galapagos. It is a deep biosphere, a hidden world of life that exists more than 3.5 miles underground. This realm is not small. Its estimated volume is more than double the size of all the world's oceans combined. For a decade, researchers from the Deep Carbon Observatory have been exploring this incredible frontier, revealing a secret that changes our very definition of where life can exist. It is a testament to the tenacity of life, thriving in conditions we once thought were impossible. This subterranean world is home to the vast majority of Earth's bacteria and other microbial life. These are not the germs we are familiar with. They are organisms that have evolved over countless eons to withstand unimaginable pressures and scorching temperatures. They are a form of life that feeds not on sunlight, but on the very rocks and chemicals of the Earth's crust. They represent a separate branch on the tree of life, one that has been evolving in isolation for millions, perhaps billions of years. Discovering this hidden biosphere is like finding a whole new continent of life right under our noses. The importance of this discovery is staggering. It suggests that life may be far more common in the universe than we previously imagined. If life can thrive in the crushing darkness deep within our own planet, then perhaps it can also thrive in similar environments on other planets and moons, far from the gentle warmth of a star. This subterranean Galapagos serves as a natural laboratory for studying the absolute limits of life. It forces us to ask new questions. How did this life begin? How does it survive? And what can it teach us about our own origins? Here is a truly surprising fact. The total amount of carbon locked away in this deep biosphere is hundreds of times greater than the carbon in all the humans on Earth. This hidden world is a massive living component of our planet's carbon cycle, a factor we had never accounted for in our models of the global climate. These tiny, deep-dwelling microbes are not just a curiosity. They are a fundamental part of how our planet functions. They remind us that the biggest discoveries are sometimes found not by looking out, but by looking down into the great unknown that lies just beneath our feet. At the center of our planet lies a world of extreme conditions. Earth's inner core is a solid ball of iron and nickel, about 30% smaller than the moon. Despite its solid state, it is unimaginably hot, with an average temperature over 9,000 degrees Fahrenheit. which is nearly as hot as the surface of the sun. This solid core is suspended within a liquid outer core, and the interaction between these two layers is the engine that drives some of our planet's most fundamental processes. The core is not just a passive lump of metal, it is the active, beating heart of our world, generating forces that protect us all. The most important function of the core is the generation of Earth's magnetic field. As the liquid outer core churns and flows around the solid inner core, this movement of molten metal creates powerful electrical currents. This process, known as a dynamo, transforms our planet into a giant magnet. This magnetic field extends far out into space, creating a protective bubble called the magnetosphere. This invisible shield deflects most of the harmful solar wind and cosmic radiation that constantly streams from the sun. Without our magnetic field, this radiation would strip away our atmosphere and make life on the surface impossible. But the story gets even stranger. Recently, scientists have detected a new type of magnetic wave rippling through the outer core. These are called magnetocoriolis waves, and they appear to sweep around the planet every 7 years. Detected by satellites that measure our planet's magnetic field with incredible precision, these waves are a direct glimpse into the turbulent motion of the liquid metal deep within our planet. It is like being able to see the weather patterns of a hidden world, a world of molten iron flowing thousands of miles beneath us. One of the most surprising secrets of the core is that it may be a source of one of life's most essential elements, oxygen. While we typically think of oxygen as coming from photosynthesis at the surface, new research suggests it can also form deep below. Under the immense pressure of the mantle, water molecules can break down into hydrogen and oxygen. This process, which creates hydrogen peroxide, could mean that some of the Earth's original oxygen did not come from ancient microbes but was cooked up in the planet's deep interior, slowly making its way to the surface over geologic time. We think of Earth's water as being in its oceans, lakes, and rivers on the surface, but one of the most breathtaking discoveries of modern geology is the existence of a colossal reservoir of water hidden deep within the planet's mantle. Located about 435 miles underground, this is not an open ocean in a vast cave. Instead, the water is trapped inside the crystal structure of a mineral called ringwoodite. The sheer quantity of this water is what is truly mind-boggling. There is enough of it to fill all the oceans on Earth's surface 3 times over. This Goliath Ocean completely changes our understanding of where Earth's water came from. For decades, the leading theory was that most of our planet's water was delivered by icy comets and asteroids that bombarded the early Earth. While this process certainly contributed, the discovery of this massive internal reservoir suggests a different story. It implies that much of Earth's water may have originated from within the planet itself, slowly sweating out to the surface over billions of years through volcanic activity. Our planet was not just a dry rock waiting for water. It had its own water supply from the very beginning. The secrets of underground water do not stop there. An entire river system, vast and complex, flows hidden beneath the immense ice sheets of Antarctica. This is not just a small trickle. One of these subglacial river networks is as large as the entire country of Egypt. It carves channels and valleys into the rock beneath the ice, flowing for hundreds of miles before eventually emptying into the Weddell Sea. This hidden plumbing system lubricates the base of the ice sheets, affecting how quickly they move and melt. It is a critical yet invisible part of the Antarctic ecosystem. The most shocking fact about this Antarctic river system is its potential impact on our world. The ice sheets that these rivers flow under contain an enormous amount of frozen water. If all of this ice were to melt and flow into the ocean, a process that could be accelerated by these lubricating subglacial rivers, it would raise global sea levels by more than 13 feet. This would be enough to inundate coastal cities around the world. The hidden river under Antarctica is not just a geological curiosity, it is a silent giant whose awakening could reshape the map of our world. The longest mountain range on Earth is not the Andes or the Himalayas. In fact, you have likely never seen it because most of it is hidden deep beneath the ocean. It is called the Mid-Ocean Ridge, and it is a colossal chain of underwater mountains that snakes its way around the globe for over 40,000 miles. That is nearly 10 times longer than the Andes. This massive ridge runs through the center of the Atlantic, Indian, and Pacific Oceans, like a giant seam stitching the planet's crust together. It is a place of incredible geological activity, where new Earth is born. The mid-ocean ridge is a divergent plate boundary, a place where two tectonic plates are slowly pulling apart. As they separate, molten rock or magma from the mantle rises up to fill the gap. This magma cools and solidifies, creating new oceanic crust and forming the mountainous ridge. This process is responsible for most of the volcanic activity on our planet. While we often think of volcanoes as cone-shaped mountains on land, the vast majority of Earth's eruptions happen silently and unseen along this immense underwater chain. It is the engine of continental drift, constantly reshaping the ocean floor. Where tectonic plates are not pulling apart, they are crashing together. When a dense oceanic plate collides with a lighter continental plate, it creates a subduction zone. Here, the heavier oceanic plate is forced to bend and slide down into the mantle. These zones are the planet's recycling centers, dragging surface rock, water, and carbon deep into the Earth's interior. They are also responsible for some of the most dramatic features on the planet, including the deepest ocean trenches like the Mariana Trench and the most explosive chains of volcanoes such as the Ring of Fire around the Pacific Ocean. A surprising fact about these plate boundaries is how directly they connect the surface to the deep Earth. Subduction zones are not just a place of destruction, they are a two-way street. The material they drag down into the mantle eventually gets heated, melted, and recycled, returning to the surface millions of years later through volcanic eruptions. This constant cycle, driven by the slow dance of tectonic plates, replenishes the minerals and chemicals on the surface that are essential for life. The hidden skeleton of our planet is not static. It is a dynamic system that is constantly building, destroying, and renewing the world we live in. In the cold northern regions of our planet, a significant portion of the ground has been frozen solid for thousands of years. This frozen layer of rock, sand, and soil is called permafrost. It acts like a giant freezer, locking away vast amounts of organic material from ancient plants and animals. For millennia, this freezer has been stable, preserving a record of past climates and ecosystems. However, as our planet warms due to climate change, this ancient ice is beginning to thaw. This process is unlocking secrets and dangers that have been buried for ages. The thawing of permafrost poses a grave threat to our climate. The organic matter that has been frozen for so long is now starting to decompose. As microbes break down this material, they release huge quantities of greenhouse gases, primarily carbon dioxide and methane, into the atmosphere. This creates a dangerous feedback loop. The released gases cause more warming, which in turn causes more permafrost to thaw, releasing even more gases. This permafrost carbon bomb is a critical tipping point that scientists are watching with great concern, as it could dramatically accelerate the pace of global warming. The consequences are not just global, they are immediate and local for a surprising number of people. Many towns, cities, roads, and pipelines in the Arctic are built on top of what was once considered solid, permanently frozen ground. As the permafrost thaws, it loses its structural integrity and becomes soft and unstable. Buildings are cracking and sinking, roads are buckling, and coastlines are eroding at an alarming rate. The very foundations of life in the north are crumbling away, revealing the fragility of human infrastructure when faced with the power of a changing planet. One of the most startling secrets emerging from the thaw is the reawakening of ancient life. In 2014, scientists successfully revived a 30,000-year-old giant virus that had been frozen in the Siberian permafrost. While this particular virus only infects amoebas, the discovery raises a chilling possibility that other, more dangerous pathogens which humanity has never encountered or has long forgotten, could be preserved in the ice. As the permafrost continues to melt, we risk releasing not just ancient carbon but ancient diseases for which we have no immunity, a true Pandora's box from the past. Our planet is constantly humming with activity, much of it completely invisible to us. One of the most powerful forces shaping our world is earthquakes, the sudden, violent shaking of the ground caused by the movement of tectonic plates. For centuries, predicting when and where a major earthquake will strike has been a holy grail for science. While a perfectly consistent method remains elusive, scientists are getting closer. They use complex models to calculate the probability of a quake based on the buildup of stress along fault lines, the places where tectonic plates slide past each other. A surprising new ally in this quest is artificial intelligence. In one promising test in China, an AI model was able to predict 70% of earthquakes in a controlled experiment by analyzing tiny seismic signals that were previously dismissed as noise. This technology is still in its infancy, but it offers a glimmer of hope that we might one day have advanced warning before a catastrophic event. The stakes are immense. A single earthquake in 16th century China is estimated to have caused the deaths of over 800,000 people, reminding us of the devastating power lurking beneath our feet. Another silent force shaping our world is upwelling. This is a simple but profoundly important ocean process. When strong winds blow surface water away from a coastline, colder, nutrient-rich water from the deep ocean rises to take its place. This deep water is filled with the decomposed remains of marine life, making it a rich fertilizer for the ocean surface. This process is the secret behind some of the world's most productive fisheries, as the infusion of nutrients fuels a massive bloom of phytoplankton, the base of the entire marine food web. However, human activity is creating a sinister version of this nutrient enrichment. Excess nutrients, mostly nitrogen and phosphorus from agricultural fertilizers and wastewater, are washing into our coastal waters. This pollution triggers a massive bloom of algae. When these algae die and sink, they are decomposed by bacteria in a process that consumes all the oxygen in the water. This creates vast dead zones, areas where the water is so oxygen depleted that most marine life either flees or suffocates. These dead zones are a silent spreading plague in our oceans, a hidden consequence of our actions on land. Some of Earth's most breathtaking landscapes are the result of hidden forces and ancient processes working over millions of years. Consider the majestic fjords of places like Norway and New Zealand. These deep, narrow inlets with steep cliffs are not just beautiful bays. They are the ghosts of ancient glaciers. During past ice ages, massive rivers of ice carved their way through valleys, gouging them out far below sea level. When the ice ages ended and the glaciers retreated, the sea rushed in to fill these immense U-shaped troughs, creating the dramatic fjords we see today. The secret of the fjords lies in their incredible depth. Some are so deep that their bottoms are dark, cold, and stable environments, far removed from the turbulence of the surface. This has allowed for a surprising discovery: thriving cold water coral reefs. We usually associate coral with warm, tropical, sunlit waters, but in the silent darkness of a deep fjord, these delicate and ancient ecosystems can flourish, providing a habitat for a unique community of marine creatures. These hidden gardens are a testament to the surprising places life can take hold, protected within the deep scars left by ancient ice. Another type of landscape sculpted by a hidden process is a karst environment. These strange and beautiful terrains form when water slowly dissolves soluble rocks like limestone, which makes up about 15% of Earth's sedimentary crust. Over thousands of years, rainwater, which is slightly acidic, seeps into cracks in the limestone, slowly widening them into complex systems of caves, sinkholes, and underground rivers. The cenotes of Mexico's Yucatan Peninsula are a perfect example, windows into a vast, hidden network of submerged caves that were once sacred to the Maya. Perhaps the most visually stunning example of a karst landscape is the stone forest in China. Here, towering limestone pillars rise from the ground like a forest of petrified trees. This incredible scenery was formed as water dissolved the surrounding rock, leaving behind only the most resistant formations. A surprising fact is that these processes are still happening today, albeit incredibly slowly. Every drop of rain that falls on a limestone landscape is part of a grand, patient geological project, silently sculpting the world from the inside out, creating secret worlds both above and below the ground. The secrets we have explored are just a handful of the countless mysteries our planet still holds. From the deep biosphere to the churning core, from hidden oceans to sleeping giants under the ice, Earth is a world of constant change and profound complexity. Every new discovery reveals that our planet is more dynamic, more interconnected, and more surprising than we ever imagined. The ground beneath us is not a static stage for our lives, it is an active participant, a living system with its own rhythms, its own history, and its own future, all of which are deeply intertwined with ours. Understanding these hidden secrets is more than just an intellectual exercise, it is essential for our survival. Knowledge of subduction zones and fault lines helps us build safer cities. Understanding the permafrost thaw and ocean acidification is critical to confronting the climate crisis. Discovering the deep biosphere expands our search for life in the cosmos. Each secret we uncover gives us a new tool, a new perspective, and a deeper appreciation for the delicate systems that make our world habitable. We are not just residents of this planet, We are part of it, and its fate is our own. The story of Earth is the greatest story of all, and we have only read the first few pages. There are still mountains to be discovered on the ocean floor, still rivers flowing in darkness, and still forms of life waiting in the deep crust that could rewrite our biology textbooks. The spirit of exploration that drove us to cross oceans and reach for the stars must now guide us down into the heart of our own world. The tools we have today, from satellites that can measure a planet's heartbeat to drills that can pierce the deepest crust, give us unprecedented access to this hidden realm. So the next time you walk on the solid ground, remember what lies beneath. Remember the churning metal, the hidden water, the sleeping microbes, and the slow, powerful dance of the continents. Our planet is a treasure chest of wonders, and the key is our own curiosity. There is always more to learn, always another layer to peel back. The greatest adventure is not in finding new worlds, but in truly understanding our own. Let us continue to explore, to question, and to stand in awe of the beautiful, mysterious, and living planet we call home.